the idea today is that we're going to show you Kartaya Maintain, which is a beta product that we've been building based on the back of Mike Vorster's work that he's been teaching for many, many years uh, in this book here and in version 1 of the same. I'm going to go through some of the principles that our product is based on the whiteboard, talk about some of the reasons that we built the product that we built, or I should say built. It shouldn't be past tense. That we're building the product that we're building. You know, it's very much a beta product. Some of the people on the call here were very instrumental in helping us get this off the ground. So thank you to you guys. And what our goal with this is to give the ability for mechanics and coordinators and other people in the shop all of the information that's inside of Vista. This is very much based on Vista's equipment module, built in, baked in. It's not an integrated product as much as it is built on top of the Vista product. So we wanted to be able to expose the data that is in the ERP system, and we wanted to build an opinionated system that puts the principles that we've learned from Mike Vorster first. And so this is our attempt to do that. Brad's been working on this for a while now, and he's our developer, Brad Hendrickson, here on the call with me, and he's going to show us the software proper. So I'll start by sharing my screen here and going through on the whiteboard just some of the things that, just a quick recap of some of the things that we've learned. One of the first things that I like to start with when we're talking about software, when we're talking about design of a new product, is why are we doing this? What are some of the fundamental principles? And in this case, there are two fundamental principles that I believe that any equipment shop should be based on, specifically the mechanics and the coordinators. Number one, the first principle is that every down event is a cost event. I can hear you thinking, wow, that's you're breaking some new ground there, Copernicus. The thing is that we have to say this very specifically. Every down event is a cost event. And that is more important than saying, well, it depends on the severity of the down event. That is true, but we do know that if it goes down, we spend money. Second fundamental principle that we base everything on is that prevention is better than cure. So all of what we're about to show you is based on these two things. Every down event is a cost event. Prevention is better than cure. One of the when we're talking about why that first principle, every down event is a cost event, why that's so important is because we know that in order to improve something, that we would like to measure it, and measuring things accurately and measuring it in a way that actually fundamentally changes behavior is very difficult. Let me walk you through why it's difficult in the world of equipment and equipment reliability, because Kartaya Maintain is specifically designed for your mechanics to increase the reliability of your fleet. Why is it so hard to measure and to quantify how much this is? Well, in a week of 168 hours, we have an amount of time that we often call the target. And this amount of time is typically 40 hours per week. We have some of you that are on the call here that might actually choose to use 50 hours as how much you can actually do as your target. If we break this 40 hours into a band of its own, we have a certain amount of different types of waste that we have related to this 40 hours. Number one is undeployed time, right? Part of the week, it's not deployed. The piece of equipment is not deployed. It's sitting in the yard. right? Our equipment isn't always on the job where it needs to be. If it's not at the job, then it's undeployed. That's a waste. We have this machine, all of our capital investment into this machine, and we're not using it. The next type of waste is down. And specifically, we have two different types of down, which we'll talk about in a bit. The down that's caused by abuse, and the down that's caused by something breaking. That's not abuse. Then we have another kind of waste called standby. And so all of this, if we take that out of the 40 hours, the remainder of the 40 hours that is not part of those three wastes is the working time. And what when we're as a shop manager, as the person in charge of the mechanics, as a mechanic yourself, you look at these different things and you say, what can I do about these? Well, really, a mechanic has no impact on the amount of time something spends working versus the amount of time something spends available to work but not actually working. That's something that is handled by the site superintendent. Also, the mechanic doesn't have very much impact on whether the machine is deployed or not deployed. That is shared responsibility by the dispatcher and by the strategic how the strategic fleet overall size, and of course by the estimators and whether or not you have the right kind of work. The only kind of waste that we can really lay at the feet of the shop and at the feet of the mechanics is the downtime. So we would like to be able to measure this. We would like to be able to say, well, how much downtime is there? And this is a difficult thing to do. It's difficult to say exactly how much of a day, how much of a week has been spent down. So, for example, if you have a piece of equipment that is shipped out to a job and it arrives there at 8 a.m. and then at 3:30 p.m., right, it breaks. And then at 7 p.m., it was fixed. How much of this time was down? Is it the difference between here for 3.5 hours? Well, it depends on how long the guys were working. What if they started at 7 a.m. and they worked until 4 p.m.? Then is the difference the amount of time that here? In other words, it was only down for 1/2 hour. Second thing is, how important was this machine? Was this a trench roller and you had a plate compactor right next to it that you could use in this particular situation? Or was this the mainline machine? Was this the most important thing on the job? Or was this something where everybody could just go home a half hour early and it wasn't a big deal? Trying to measure how long something is down is very difficult, and trying to measure how severe the down event was based on its length of time, based on the cost to fix it, based on the impact to the job. What if it was something? What if it was a if it was a low boy that broke down and it broke on the I-5 bridge right before a barge came through and they needed to lift that up? How severe is that down event, right? What about if that same low boy broke down inside at your yard? It's very difficult to exactly put exact dollar amounts on this or exact hours on this. But we know that because it's something that we want to improve, we want to make this shorter and we want to make these things less frequent, that we want to measure them. And since we want to measure them, we have to find a different way of measuring them than simply saying hours or simply saying dollars and laying that at the feet of the mechanics or the mechanic shop. So what we've done is we've borrowed from the safety organizations, and maybe you guys are familiar with this. You drive into some kind of industrial complex. There's one, for example, at the dump here in Clark County, that there's a big sign and it says days since last accident, right? And they have this big number here, and you're like always a little bit scared if you drive in there and you see 0. And it's kind of comforting if you see 100, although at the same time you're going, okay, is it today the day then? But anyways, they are not measuring how bad the accident was, and they're not measuring how long or what impact in hours that accident had. They said days since last accident. Another way of looking at the same data that safety managers often look at is what is the frequency of this. That is, over a length of time, say over a course of 3 months, January, February, March, how many of these accidents were there? Right? And you can say now that over a 3-month period of time that we have had 6 accidents, right? 6 accidents, or if we divide that by 3, we get 2 accidents per month. People are often looking at it this way. They go one step further in safety, and they start talking about man hours. How many man hours did we have in this time period? And so maybe they have 1,000 man hours a month in a small company, right? And so now we can say that there was 6 accidents divided by 3,000 man hours, or you can flip that around and get a little bit better number, and you can get a small decimal. I can't do that math in my head. A small decimal that gets you to 0.0005, something like that. That allows us to have a metric that relates to the number of accidents. So we've borrowed this same kind of terminology when we're talking about down events on equipment, the same thing that was in safety. That is, we know that we need to measure this because we need to lay the down events, the cost of these down events at the feet of the people who can actually do something about it. We know that it's difficult to measure in hours or dollars what these cost. And we know, going back to this first principle here, that every down event is a cost event, and we want to reduce the frequency of these, since they all cost money, even though it's difficult to know how much. So our measurement that we're looking at is the frequency of our down events. We simply say, over a time period or over a number of fleet hours, what is how many down events do we have? That is, we measure this frequency of down events over a time period or over a number of machine hours, often life to date. The other thing that this allows is it allows us to start looking at these things as specific events. So we don't only care about the cost of the down event. We also care about other things like morale, and we look at how often these things are breaking down, so that we can make better decisions about our pieces of equipment. With the idea that if we're measuring the frequency, that we can also now prevent this, that is, lower the frequency of these down events from happening. So the next question that we have is, well, how do we actually measure the frequency? What is it that allows us to say this has happened, this hasn't happened, and gives us a fairly good metrics, pretty good data? Now, all of you guys that are on the call are Vista customers. You have Vista, you have the EM module, and inside of Vista, oftentimes people who are just getting started, they're tracking their equipment, and they're tracking all their costs on cost codes. And within the cost codes, they're tracking their cost types. And this allows you to see over time the amount of money that you've spent on individual cost codes and cost types, and you can actually get reports that say your total cost for a piece of equipment, or you can say your total cost for multiple pieces of equipment all within a single category, right? And you can get the cost that you have for a particular rate category, right? So you could say, how much have I spent on these particular cost codes for my mini excavators, right? But the problem with this is that it doesn't allow us to differentiate between this. It's kind of all one big soup. All the costs that we spent on particular cost codes. If you have good cost codes, you can tell where you spent the money, right? On the machine, maybe you spent it in the cab, maybe on the electrical system, right? Maybe in the transmission, maybe it's on tires. You can see all of that, and you can see the cost types that split across, labor and parts. You can see subcontracted costs in there, but it doesn't allow you to group it in any meaningful way that would allow us to get a metric for the shop. That is, that would allow us to help the shop reduce and control downtime. In order to do that, you have to go the next step further inside of Vista and start separating these costs over time. That is, we have to take these and put them on a timeline using work orders. Now, Vista allows us to have a work order for every single event, right? And all we do with a work order is we take the cost from a cost code and cost type, and we say, this is happening on a particular work order. What we assign at the time of the work order, often anyways, is the date that the work order happened and the hour meter at that point. So now we've grouped these costs into a particular work order. And these work orders, of course, they happen over time. We have all sorts of different work orders. And now we can start to say, well, what of these work orders were work orders that resulted from equipment going down in the field? Which ones of these were down events? And then we can say during this time, from here to here, how many machine hours were there? If there were 3,000 machine hours, and we have 1, 2, 3, 4, 5 red events during this time, that means that we have 5 red events divided by 3,000, or we have let's see, I really should make my life easier and make it 6, huh? It's nice to have a whiteboard. So that we can say, how many is this? This is 2 per, I can write this out, per 1,000 hours. 2 per 1,000 hours. This is often how we talk about frequency when we're talking about a piece of equipment. We have 2 per 1,000 hours over the life of this machine. Well, in order to actually calculate this in a meaningful way, that means that we have to put little tags on these. And we have to say, what type of events are these? Luckily, Vorster has given us a tagging system that makes a whole lot of sense. And the tagging system that works really well, that is real meaningful to the mechanics, is a color-coded base system. First of all, we have our regular old down events. The ones, I hope they're not as regular as all that in your guys' companies, but we have our events that we call red events. This is what I call a backronym. This is reported emergency down, RED. These are our red events. These are the ones that we are really hyper focused on and for the equipment shop, and we really want to reduce. We also have black events. Black events are ones where they're down due to abuse. So unlike red events, black events were preventable. They happened because of something that happened in the field, usually the operator damage. Then we have blue events, and these ones are abuse, but not down. So both of these two here are abuse type work order tags, and both of these here are down, but for different reasons. We also have another series of codes, another series of tags that we like to use. One is orange. Orange is condition-based maintenance. This is the machine telling us that it needs maintenance. This is the result of an inspection telling us that this needs maintenance. This is oil sample telling us that this needs maintenance or needs a repair. These are the things that we're able to fix on a work order before they go down. Oftentimes, a neglected orange event will lead to a red event in the future. We'll definitely return to that. Then we have our green events. And our green events are preventive maintenance. Preventive maintenance. This is anything that happens on a schedule of any sort, whether you do it per calendar over a calendar time, or whether you do it based on some kind of hour meter, right? Very frequent that we see 500 hours service, or we see the 5,000 mile service. This is preventive maintenance as our green events. And finally, we have what I call our gray events. And our gray events are any capitalized repairs. So our gray events are capitalized repairs. This is a side note for any of you who are accountants in the audience. Any gray event, this allows us to capture the entire work order by tagging it as a gray event, the entire work order. So we have the parts and labor, and to capitalize the entire work order, the entire cost of the work order as necessary, if it's appropriately tagged as a capitalized repair. So these are the different tags that we have, right? So now we've used Vista to say, not only do we have our equipment broken into equipment rate categories, but we've broken down our costs from our cost codes and cost types only, or the big soup per piece of equipment, into something that is much more chronological, something that gives us a date and the hour meter, and a simple cost coding system. We actually created a poster for the wall of the shop for some of the shops, so that you can actually see this right on the wall of the shop. You can see all of these different cost codes. This is something that we want to say, because obviously if we can look at this, we don't want to say how much money did we spend on this piece of equipment. If what we really care about is how much money did we spend, or more specifically, how frequently did these red events occur. So if we start measuring how frequently these red events occur, what we can do with this information from the perspective of the machine itself is we can start tracking it over time. And we can say, if we say over here, frequency, and over on the x-axis, sorry about that. On the x-axis, we say machine hours. We can start tracking how many red events happen. Of course, at the beginning of a machine's life, it's relatively low per 1,000 hours, and over time it curves up. And of course, any of you who have been around Vorster and his work know that it doesn't just go up linearly, but at the end of a machine's life, it actually has some sort of exponential component to that. That was supposed to be a lowercase n to the x. That is an exponential component to the curve as it goes up. That is, not only does it go up in frequency, but that frequency tends to go up faster as it gets older. It accelerates. And so we can start to use this frequency as a leading indicator. So we can start to say that if this is today on the graph, and of course that means that we don't have this part of the graph yet, but we've seen many different red events on our timeline, and the frequency is rising, that we can predict with reasonable accuracy that for a machine or for a rate class that our frequency is going to get worse over time. That is, we can predict that there are going to be many more down events here, and since a down event is a cost event, we can predict that the cost that will occur there. Not with any kind of reasonable accuracy. We can't say, oh, it's going to be $1,527.32, but we can say there are going to be a lot of cost events in our near future. We need to consider getting rid of this machine. I didn't say this should be the thing that says you need to get rid of this machine. That, of course, always should be a conversation with the people who actually understand the machine, especially the mechanics, the shop operators, and the person who's in charge of the fleet acquisitions and disposals. But this metric here, the frequency of down events, can be something that can wave a red flag to say, please consider getting rid of this machine, even if it's before your sweet spot. The other thing that tracking your down events can do is it can give you a very good KPI for your fleet as a whole. So now, if we say over the course of a full year, we split this up 2, 3, 4, 5, 6, 7, 8, 9. Oh, didn't have enough months here. 9, 10, 11. There we go, something like that. We can start to look at the frequency of red events per 1,000 hours operated in that particular month. So maybe we have 2 red events per 1,000 hours here. Maybe we have 10 red events here, right, per 1,000 hours. Maybe we have 11 events here. Maybe we have 0.5 here. And we can start to look at this metric, and then we can say, well, what happened during this time? And we can sit down with the shop foreman and the field mechanic foreman, with the shop coordinator. We can sit down and ask the question, why did we see this spike in events that happened during this time? And maybe you'll find out that, well, in the months previous to this, Jose, the preventative maintenance guy, had been on vacation, and that he was the guy who was also performing the mechanic inspections, and so there was a corresponding drop of green and of green events and orange events, condition-based maintenance, in the months prior to that, and so you ended up having a lot more things break in the field. Or possibly what you see is that you had some fairly old equipment. Maybe you had 3 different excavators that all were replaced right around here. And in that replacement, it made your down events go way down. You just had worn out equipment. But it allows you to look at that, and also gives the shop manager something that makes a lot of sense. A lot more sense than just saying, hey, it broke again, I can't believe that you screwed up. Because we expect a certain amount of down events. If we don't have down events, that means that we're either driving a completely brand new brand new fleet, which is possible to do. It's just very capital intensive. Or it means that we have such a robust system that we're spending an inordinate amount of money to make sure that all of our equipment is in top-notch shape. A man I talked to worked up at the air base in Alaska. He was responsible for the Air Force's fighters that were based out of there. and they had an extremely intense maintenance program to the extent where they were counting every single screw that went out into the clean room and counting every single screw that came back to make sure that there wasn't anything ever left there. Those planes were not allowed to go down while they were flying. And the Air Force was willing to spend the money on that. As contractors, we're typically not willing to spend the money on that, and therefore we're willing to instead allow a certain amount of this to happen. So with this, we can measure how many are happening, and we can set a benchmark for our shop, right? We can now turn to people like you, Robert, and say, Robert, this is what we expect per 1,000 hours, and now you have something to measure yourself against. Are you doing better or worse than that, based on the numbers? And of course, we can start to measure things like the amount of money we're spending to make that happen. The last thing that this allows us to do, using Vista to tag work orders and to look at them, is it allows us to do one of the fundamental principles of lean manufacturing, right? Now, this was something that we borrowed from Toyota, and that is that we get to ask the 5 whys. Why did this happen? And then you dig down into that. Why did that happen? And you dig into that. Why did that happen? And why did that happen? And we can do that in the specific context to allow us to kind of look at, well, what kind of failure was this? Because we can put this in a 2x2 grid. And in some cases, the signs of failure are easy to see. And sometimes the signs of failure are difficult to see. Right? Now, of course, it's nice when you have a whiteboard and you can draw just a nice, clean, sharp line, right, between easy to see and difficult to see. And this is a spectrum, and there's gray area and all that. I understand that. But if something fails, why, it is very, sometimes it's very difficult to see why it failed. It's a valve cover that's in, very deep in the engine. It's difficult to see that. Sometimes it's something that's really easy to see, right? A simple inspection would have found that. There's also the ones where you intend to avoid the failure, and there's the ones where you intend to run to failure. Now, this makes sense in this context right here, right? The things that are difficult to see, there is a certain amount of things that we intend to run to failure. We're going to keep driving that truck until it breaks down because there's no easy way to inspect that. We can't send in oil samples. That we don't know what's going to happen with that particular component or that particular thing. We're just going to run it to failure. Once it breaks, we're going to diagnose it and fix it. These things are just accepted as part of business, but they can be down events, right? Here, the easy to see and the things that we intend to avoid, right? These are all of the stuff that happens because of a good inspection program, and the work can be planned. Work is planned. It's important that we try to get as much as we can into that box through a good inspection program. It's these other two that we're looking at. First of all, if it was easy to see and you ran it to failure, this means that the downtime was unnecessary. And so when you're asking these 5 whys and you see something that it was a down event, and you can say that it was run to failure, that is, we didn't do it ahead of time, we didn't avoid the failure, and it would have been easy to see. Now you can ask, why did this happen in this quadrant? How in the future do we get the red event that just occurred into something that would look more like a green or an orange event? And then there's also the things that are difficult to see that we can avoid, and this relies on statistics, and being conservative. Stats and conservative. So, for example, one of the ways that you can be conservative is that you can go and change the oil on a machine every 250 hours. Just across the board, we're always going to change it every 250 hours. But of course, that means that compared to somebody who's doing it every 500 hours, you're spending twice as much money on oil and on the maintenance itself, right? But if there's something that is difficult to see and is fixed by making sure that the oil is changed, then by being conservative, we can make sure that we don't run it to failure. We avoid the failure by being conservative. The most obvious way of being conservative is to just buy brand new machines and sell them at 1,000 engine hours, right? Every single machine in the fleet, if it's once at 1,000, send it to the auction. That's somewhat similar to what we see with the rental car companies doing that, with the consumer rental cars. A lot of times you don't often rent an older car, which means that they're getting rid of it, right? They're being conservative. That's one way to do it, to avoid failure. So when we're doing these 5 whys, we're asking ourselves, what type of red event was this? Was it a down event that we simply have to accept? Was it a down event that was easy to see? If it was easy to see, how do we avoid failure in the future? Maybe that's a training thing. If it was difficult to see, how do we maybe get to make our repair and maintenance operation more conservative, to be able to accept it, so we don't have to accept that? Or maybe possibly we do something like more frequent oil sampling, so that we can make it so that it's easy to see. That is, something like a lab can help us make it easy to see. So one of the main reasons we do these work orders and we do these work order tagging is so we can actually investigate it. We want to be able to we want your own team to be able to pull back from the work, and once in a while, maybe once a week, take the worst red event of the previous week, get all your mechanics together and go through the 5 whys. Look at it in the context of this graph and say what it is. Well, all of this is great, right? Our goal is to have 0 on-site failures, and we want to plan the work, right? Like it says here, we want to plan the work, and we want to make it so that we can avoid failure. Part of the next kind of thing that we found was that even planning the work is difficult, right? Just because we have a work order doesn't mean that we plan the work. And the key there was that even if we have this list of work orders, and somehow we have this up on the board, on the wall, like they used to do in the old days with the 3x5 index cards, and we say, okay, work orders, right? Well, there's a difference between a work order and a work order that is ready. What is it that makes a work order ready? There's all sorts of things. There's scheduling. There's parts ordering, right? There's mobilization of the equipment, right? There's diagnostics. And all of this stuff has to happen before it's ready. So so just tagging it with the appropriate color, we found wasn't quite enough. We also had to give the ability to make the work ready. And we found very early on, well, I can say on my first implementation, the head of the equipment shop, who some of you guys know quite well, told me, Michael, when we switched to Vista's equipment module, it was like someone had taken away our smartphone and given us a flip phone. But he said all the numbers were right. And that was the problem that we've been wrestling with for the last 10 years was, yeah, we have this system that allows us to do these things here, to track these. It allows us in theory to get to say what our this KPI, how many red events per 1,000. It allows us in theory to ask these to bring up what actually happened and to ask these questions with the mechanics. But because it's not easy to use, for example, by making work ready, and because it's not something that is easy for anybody other than somebody who's a trained accountant to actually get in there and do, that it was very difficult to actually get this information inside of Vista. So we've been working on this Kartaya Maintain to try to make that work, to try to make it so that It was easy to get the information in and easy to plan the information so that your enterprise resource program could be used as a true enterprise resource program. And that's really why we did this. We're trying to make the accounting system be only an accounting system and interface, or I can say build upon it, so that we can have the mechanics do what the mechanics do best, to have the coordinator do what the coordinator does best. So those are some of the fundamental principles that we've built on. We're trying to make work ready. We're trying to measure the frequency of down events by being able to easily tag our work orders. We want to be able to figure out how many red events there are per 1,000 hours. We want to be able to track all of this. So we've started this process, and Brad has been the primary guy doing this, and he's going to show us around kind of where we've gotten to so far, with the help of a lot of you guys that are even in the audience today, of showing us some of how you guys work and allowing us to see what needs to be done. So yeah, go ahead, Brad. Take it away from here. Show them the product itself, and then we'll leave some questions at the end for some questions and answers. You can always throw questions in the chat. Also, there's a few enough of us here that you guys can feel free and just turn on your microphone and ask the question as well.
Yeah. Okay. So Kartaya Maintain. Let me share my screen. All right. So here we are. 1 second. So yeah, there is a lot going on in Kartaya Maintain, but not a lot of complication, I guess. So we'll start by going through how we make work ready in Maintain. This all kind of starts at the request service screen. So this is where the operator of the equipment, let's say I'm the operator of the equipment and I have an issue with a piece of equipment. Let's see. There we go. And I have kind of an example here. Let's say my name is David and I have a van truck and the engine's running rough. And then, so this basically is a place for me, the operator, to file my issue with the equipment outside of like an inspection or something. So if I notice something's wrong, I can create a service request. So if I create that, then that will show up for, let's say I'm the coordinator now and I'm running the shop and I want to figure out what the field issues are. So then I can see my new request come in here in this inbox. And this is kind of a list of requests. And these requests just have the equipment number and a name and maybe a date and a description.
Did we lose him? Well, that'd be handy. Right in the middle of the webinar. I guess then I'll just ad lib until he gets back. I wonder if he lost service. That's great. What he was showing you there was the specific part of. Oh, you're back,
Sorry, everybody. I'm back. Yeah, my team's crashed.
Oh, good.
Anyways, I'm back. Here, let me share my screen again.
I was just gonna start ad libbing.
Okay, great. Let me pull you guys back up here. I got my screen shared again. Okay, yeah. So like I said, I created this request, and now I can see it in this inbox, and it has just the rough details of what was going on for this operator, who was me a few minutes ago. And this is basically something we can turn into something to do. But I'm going to go back and break down this service request screen a bit more. So here I can enter those details, but because I have to log in to get here, and a lot of times your operators and people in the field aren't necessarily going to be as plugged into the mechanics operation. Each company gets their own basically private public URL so that people from the company can go and submit the request without needing to log into the software. And then those requests will show up in the request inbox, like I showed. And then this request page can be accessed via scanning a QR code. So for example, I can generate one for this example company here. And if you scan this QR code, it will take you to the page to enter a service request. You can also generate a QR code for a specific piece of equipment. And that will get you a URL, which gets you to this page again, but it just pre-fills out the piece of equipment. So that way you could, for example, stick this inside the cab, like on the windshield, and then you could be able to scan it and get to enter a problem with the piece of equipment from the field. And in the future, we'd like to also have things like inspections and updating the meters and things like that in this form or from that QR code, so you can easily get to those things that you need to do while you're in the field. But let's continue along our path of the making work ready. So we have our new request showing up here in our inbox. And let's say we wanted to turn this into something to do. So I'm the shop coordinator and I want to create a work order, or I want to work on this guy's problem. So I can move it over here to this work pending list, and I can pick a repair type, which you can see here is color coded by the color for the type of work order this is. And so this one, the engine's running rough, so we'll pick condition-based maintenance. It's still up, but we have a problem with it. And for our cost code, we'll pick tune-up. And here we can also enter some better details for our mechanic operation to be able to actually do this work. So the engine's running rough is kind of a brief description and not very helpful for our mechanic. So maybe we could call this guy and figure out, what's wrong, or maybe provide some more detail. We can also create a title for this work pending. So in this case, we'll call it rough idle or rough running. And maybe we call him and get some more detail, or we text him or whatever. And he says, it feels like it's misfiring. And has a loss of power. And now that we've updated these details, we've kind of turned this into something we can do. Then we will go ahead and save it. And now we have created a work pending. The work pending screen basically shows you a list of work that is ready. So here we have a list of things that we have identified that we want to do, and we are going to go ahead and do them when we decide to. So you will see the notes for those. And so here we can see our new rough running work pending at the top of the list, and its repair type and cost code, and then you can also see the color of it. And then you can also see, for example, pieces that have already been created into a work order. So these work pendings have already been assigned to a work order to do the work. And then you can also see ones that you've archived. So let's go ahead and we'll go and build or do this work. So we can come find our rough running one here on this van truck, and we can see there's also some other existing items, but we can drag it over here, and this allows us to create a new work order to do the work. We could also, if we wanted to, we're still doing this repair damaged taillight work order, we could add it to that work order as an item and do it on that work order. But let's move it over and create a new work order for this. So now once I've done that, this will create a work order inside of Vista. So this work pending list, and before that is kind of just a prior step to save our progress and get that work ready. But here, I'll pull up Vista and show you in here. Let's see, we created number 115. And so, oops, grab my test system. All right, so we have our that'll create our 115 rough running work order, and we've got one item on it for the work pending that we created. And so here's our cost code and our status. And then we have the notes from that. These notes came from the work pending, or from the service request. And then, yeah, so then now we are ready to do some work. We can enter time to this, or etc., and update the notes. And so if we wanted to, we could also throw one of these other things. Let's say we wanted to add this check breaks to this work order, and then we could add another item there. And so now I can see in maintain, here is this work order in maintain. So this is also in Vista. So basically any work order data, time entry data, things like that inside of maintain are coming straight out of Vista. So if I edit this work order here, then that's editing the work order in Vista. So I could, change the assigned mechanic, update the description, things like that, and it'll happen in Vista as well. So we can see our two items here. We have rough running and check breaks. So now we've kind of gone through the main kind of path line of creating a work order, but there is a little shortcut. So let's say you have something that needs to get done right away, and it's coming to the shop right now, and you're going to do it when it gets there because it's a big emergency. You have a shortcut if you still want to have a work order to be able to track that, and you don't have a service request yet, and you don't have work pending yet. You can create a work order just like you could create a work order in Vista. So let's say I have this 115 SR excavator, and let's say this one has track is detached. And we could, let's assign it to me. Well, me as in William Chen, the example coordinator, not me as in Brad. But and then we can create that work order, and that'll just create us a work order stub in Vista. So we've got just the header side of it. We've got our description that we created and all those other things. And now we can add some items to it. So we'll call this item attach track. And for cost code, we will pick, let's say, we'll go with heavy equipment repair on site. And for our repair type, we're going to pick reported emergency down. And for our status, we'll pick in progress, since we're going to do it right now. You can start a new work order item at whatever status is currently at, but we'll pick in progress, and we'll hit save. Actually, we haven't assigned it yet. I'll do that. So I'll put it to be assigned. So then we have our new item, and here we have a work order to enter time to as well. So that's basically kind of a shortcut if you need to, if you already know what you're going to do and you just need to get it created. But in the other cases, like with the work pendings and the request inbox and stuff, you can see stuff coming and plan out your work. So speaking of which, one other thing that this work order builder shows you is here. So these are all our work pendings that we've created, but it'll also show us standard maintenance groups inside of Vista. So here on this Mack dump truck, we have a oil change that's due in 25 hours or 52 days, and I can show you in Vista where that's set up. Let's go to standard maintenance groups. I'll pull it up on my screen in a second here. Okay, so here we have our standard maintenance group set up in Vista. We have the dump truck, and we've created a dump truck service maintenance group, and it has one item for changing the oil. And here I have it due every 500 hours and to warn within 50 hours or every 180 days. And then so inside of here, since if we look on this standard maintenance group, I'll pull this back up actually. Inside of Vista, if we look at the grid here, we can see is last performed at 3741 hours. And if we look inside of here, we have the hours on this piece of equipment is now 4216. So it's due in 25 hours, and it warns us that it's going to be due soon. So now we could turn this into a work order as well And we could do that oil change from the standard maintenance group. So we can say, okay, we can know ahead of time that this is going to need to get done soon, and we can plan that work out. We could also, if there was any more work pendings on this dump truck, we could add those to that work order as well, if they were something we could tackle in that, work order. All right, so that's the whole process of making work ready, creating work orders, and getting that all set up for the mechanic to do the work. And so now I'm going to sign out of William Chen because I'm not going to be the coordinator anymore. And now I'm going to sign in as a mechanic, and I'll show you the process of doing work in Maintain. So my example here is this guy, Benjamin Kim, I've created, and I'll sign him in, and here we are. So let's go through starting with looking at what we need to do. So if we look at our dashboard, we can see that we have an assigned work order and we have some scheduled work to do. The scheduled work is based on this mechanic planner, and the assigned work orders is based on the work order assigned field on the work order itself. So if I go to, let's say, this work order 109 that we have assigned, I'm assigned as the mechanic on this work order, so it shows up on my dashboard as an assigned work order. Also, if I was a coordinator, I could see my different mechanics and which work orders they were all assigned. So I could go through and see basically for each mechanic what work orders they have assigned. But so as a mechanic, I can see I'm assigned to do work order 109. Now, I can also go here and find that work order, but it's linked inside of the dashboard. And also my other scheduled work is linked here as well. And then, so the actual planner is a 3-day plan, and it shows you basically your next 3 days and what is scheduled to do there. Over here, we have some work orders that are unassigned. So our new rough running work order that we just created as our coordinator, and we have a work order for replacing spark plugs that we also created recently. That's not assigned. We have the assigned work order. So this is that 109 that's assigned to us. And then you can see our schedule. We have this work order here today, and we have something scheduled for tomorrow as well. And so if you are a coordinator, you would be able to schedule this basically for each mechanic. And as a mechanic, you can schedule things for yourself. So let's say I was going to do this rough running work order, and I'm scheduling it for tomorrow at 1 p.m. We could just drag that to the calendar and schedule it out. And then that'll also let us get to, these calendar events will let us get to various activity on the work order. So we could go to view the work order itself and get here, or we could go to enter time and details to it and get to this screen, which I'll show you in a second. And so that's kind of the gist of the calendar. It lets you plan out your day and the next day and the next day. And you can see what's assigned to you and what's unassigned. So if you are going to, take responsibility for these work orders, you can drag it to your calendar and it'll actually assign it to you. So I drag this rough running work order. As you see, it's no longer an unassigned work orders. It's now in the assigned section. And if I go here, I'm assigned on the work order. And also, if the coordinator was scheduling for the mechanics, which you can do, that it will assign it as well. So if I was, scheduling for somebody else, then I would be able to drag it to their calendar and it will assign it to them. And that just basically keeps so that the calendar matches the assigned list. Second. Okay. So my mouse was waking up. Okay, so once you've got things scheduled, you can actually do the work. So that consists of going to the work order, and well, you can pull this work order up while you're working on it. And let's go to our work order 109 that we have assigned for these engine repairs. And we can see we have 2 different items. We have one for replacing worn belts and hoses, and we have a completed item for repairing an overheating issue. So if I was working on this work order, I can pull up this work order and see the description details and see the items on it. And then we can also get to a spec sheet, which will show us the details that are in Vista about this piece of equipment. And we'll also be able to see any standard parts. So in Vista, there's a tab for standard parts that'll show you can have like your oil filters and things there. And you can also see any attachments in Vista. So this will show Vista attachments. So if you go to like the little paperclip in Vista, that'll be, it'll show those files here. So you can see any, maybe any service documents or things that you've attached to the work order, or manuals, things like that, to help the mechanic do their job. So let's say so I'm Benjamin Kim and I'm working on this, and I've already got this item number 1 completed. So we're working on replacing the borne belts and hoses. So I can go to the edit work order and I can see the 2 different items on this work order. And I can also update the odometer and hour meter that this work order was performed at. So let's say this excavator is now at 1,000 hours. When I started this work order, I can add that to the work order so that we know when this work was performed. And so now we can see our different items. We can see I've worked on the diagnose and repair overheating issue on 5/8 yesterday, and I did 3.5 hours there. And we can also see the timeout here. And we can see here's our notes from that, and we replaced it with an OEM thermostat. So that issue is done. Status is completed. So we'll leave that one be for now. And now we're working on this more worn belts and hoses one. And so here we can see, okay, we replaced the radiator hoses, but we need to replace the belts. So now I'm going to do that work. I replace the belts, then I can update this and I can say, okay, I'm going to update the notes. And we'll say that we replaced the timing belt and the AC belt. Say serpentine belt too. I guess it depends. And we can update the status to, in this case, we finished it, so we'll update it to completed. And, or actually, let's say we still have 1 belt to go. So now we can actually say, okay, needs new AC belt, part ordered. And we can put it for waiting for parts and submit our time. So now we've actually got some more time entered, or actually I didn't put any hours. I updated the status. Let's actually enter our time. So let's say we started at, it's now 11:35 right now, but let's say we started at 10 a.m. and now it's 11:30. So, oops, a.m. So then that was 1.5 hours. So that'll actually calculate the hours for you if you want to use start and stop time, but it is optional and you can enter your time separately. So I could put 2 hours or whatever here. So I'll submit my 1.5 hours, and then we've got an extra line for today now. And so that just lets you see the time here. So we've done some work and we've updated it. And now if we go back to the actual work order 109, we can see that this is now waiting for parts, and we've got it all finished up almost. We just need to get that one part and then finish it. So now we can go to the mechanic time card, and this is where the mechanic can review and enter their time. So if we look at all days and period, we can see that we have our time from the other 2 days where we were working on the item 1 of work order 109, and we were also working on item 2 a little bit. We did 1.5 hours that day, and we did also 1.5 hours today. So if we can also filter by day. So today is Tuesday. So we've done this so far, and we've also done on Monday those other 2 items. And let's say today is Tuesday, and we could add work order time here. So you can pick which work order you're working on, and it'll fill the equipment, and then you can pick which item you're working on and enter the time here. And you can also enter the memo and the start time, stop time, and hours. So that's another way you can enter work order time, although it's easier and better to be able to do it at the same time as like the status and all that. But you can also enter miscellaneous time, so some kind of shop time. Let's say I was helping clean up or inventory. Maybe I spent 2 hours on that. Then we basically have some more time we can add there just for outside of a work order. That way we can handle all of our mechanics time entry. And then the coordinator would be able to switch between the different mechanics, and you can to review the time before it gets processed. And yeah, that's the mechanic time card. And that's kind of the whole workflow. There's a couple more little things on the work order screen I can show you too.
Real quick, Brad.
Yes.
And what when you hit save on that mechanic time card, it's already in Vista, right?
Yes, correct. So the time that you're entering in this mechanic time card is going into a payroll time card batch inside of Vista. And that way, once you're done entering for the week, all the you can maybe have the shop coordinator or foreman review the time, and then have the payroll person process it from Vista, and then you get paid out of Vista. So basically, it prevents you having to double enter or somehow import your time cards into Vista. It just goes straight into a Vista time card batch, and all is well. So you can see here, the pay period you can select here will show you the open pay periods. And it also won't let you enter time to a pay period in the future until you've started that pay period. So once it's activated, there'll be a batch in Vista, and you'll be able to enter your time to that pay period. So yes, this is another part that's basically all the work orders, the time entry, and things like that are in Vista. The only things not in Vista that are in the software are basically the kind of tracking outside of Vista, your service requests, your request inbox, and your work pending, and the planner. But yeah, that time is in Vista. But then on the work order, there's a few other things you can do. You can close a work order, and this in Vista, when you close a work order, this will also update the last performed hour odometer or hour meter for a standard maintenance group. So let's say I had created a work order with a this oil change one, then it would reset the interval on this so that it's another 500 hours or whatever. So that way you can, and this auto pulls in from what I've specified when I started the work order. So I can say what odometer and hour meter the equipment at. This is not updating the meter reading, but this is more saying we did this work order at this meter reading. So yeah. And then when you close it, it'll update the interval with what you had set that work order to be done at. You can also set the close date and the close status. In Vista, you can have different final statuses. So this supports as many final statuses as you might have. Most people only have one for completed, but it's a drop down. And then so let's say we finished this work order. So everything is done. This one's still waiting for parts, but we can set it completed and then hit close work order. And it will update all of our statuses to completed, and it'll gray out this close work order button. And now we have closed our work order inside of Vista. So if I go into this work order in Vista, it will be closed. One other thing you can do inside of Maintain is, like I showed earlier a little bit, there's attachments in Vista. So in Vista, let's go to our work order 109. Oh, I don't have it open anymore. And let's open that up. And so there's this attachments thing at the top. We don't have any attachments attached here yet, but you can pull up this attachments pane and see the files. So I'll go back here and let's choose a file. So let's say we just wanted to upload a picture of the equipment as it happened on this work order. So work order 109 here, we are working on, I think this was an elevator. Yeah. So let's upload a picture of this excavator here. And so you can pick your file, and when you upload this attachment, it will actually create oops, I actually refreshed the page. That's right. So it'll create that file inside of the attachments database inside of Vista. And you'll be able to see the file there, and you can also see any attachments you've attached from Vista. So people working in Vista that attach files there, you'll be able to get at them from here. So if I go in here and I go under attachments, let me refresh so I can see the new attachments. Then you'll see we have this new file, and we can take a look at our picture we've uploaded, or a PDF maybe if we upload like a title scan or something like that, or registration maybe. And then so this allows you to basically attach files to your work orders, and we're planning on rolling this out in various other places here, because you can attach files in a lot of places in Vista. And this kind of is an extension that lets us get at those files and also add files from in here in a simple way.
And then so if that that the using the camera on an iPad is also available. So you can just if they're filling out a work order, then those things will also attach.
And that also works on the service request. So you can, this attach photo button will let you pick a photo if you're on a computer, and it'll also prompt you to open the camera if you're on a mobile device that has a camera. But yeah, that's, I guess, the whole breakdown. I guess we might as well go into some questions.
Yeah, perfect. Thank you, Brad. Yeah, so let's open it up for questions. And there's a lot of stuff that's here. One of the things that is definitely true is that we have a lot of things that we would like to get in here. We have all sorts of different reports, some of which we built for you guys in Crystal Reports or SSRS inside of Vista that we'd like to incorporate in here, get some nice graphs showing frequency over time, that kind of stuff. There's plenty of stuff on our backlog as we go. The way that we're prioritizing it right now is the people that are in the beta program are the ones who have who basically have priority on the features that are most important to them, and we're working on putting all those things in. But yeah, questions for Brad? Anything that you guys would like to see? Any questions of how it works? And feel free to just unmute yourself, or else if you don't have a microphone, go ahead and use the chat. Awfully quiet. I think you've just wowed him into silence, Brad. Hector.
Wait, Hector is raising his hand.
Hector is raising his hand. What does that mean?
Hey guys, hope you guys are doing okay.
Oh, there you are. Yeah.
Hi, Hector.
There we can hear you. Hi.
Quick question: how's your integrations part working with Vista? Like, are you guys reading information from Vista every so often, and you're uploading information back to Vista? Do you guys have any issues with that?
So the way it works is we have our own service that runs on the database server that interfaces directly with Vista's database and allows us to read and write data to the Vista database directly, just like Vista would do while it's operating. So it basically lets us add and modify data live on that database without having to do like a daily upload or an import or anything like that. So as opposed to being like a kind of a slower integration, it's very tightly integrated. So it's basically right on top of that Vista database. So anything you create is instantly inside of that database. There's not like a cache, there's not like a secondary database. That is where the work orders live, and that's where the time cards live and those things directly in the Vista database. And the only things that aren't in the Vista database are things that don't need to be there. So like the service requests, for example.
Thank you.
Yeah.
A question from Sharon. This is still in beta. Would it require a VRL connection to Vista? That's not installed on the cloud server. That's the first question that she asked.
I can answer the first question there. So we have this installed on both Viewpoint Cloud and on-prem installations right now. So it'll work with any Vista installation where you have access to the Vista database. So we personally, our Vista is on.
You muted yourself.
Huh? Oh, someone muted me. Maybe it was you, Michael. But yeah, that. As for price range and stuff, that's a Michael question, I think.
Yeah. So our price right now is what we're basing it on is basically anything that you're going to service your equipment on. We're figure that we're going to base it in the future. This is preliminary pricing, but we're basing it $3 per service piece of equipment. So, for example, we have if you have the let's just say you have all your shoring boxes and maybe light plants and whatever else, little things that you have in there that are pieces of equipment inside of Vista, you're not getting charged for those, but you are getting charged for all of your excavators, all of your trucks, all of that kind of stuff, anything that you actually are servicing. Sharon asked the question, are time card entries still visible and maintained after posting or processed in Vista?
So yeah, once you've posted it in processed in Vista, it's not visible and maintained as the batch no longer exists in Vista.
There is one place that it is that you will see some notes on the work orders themselves for the previous stuff, but they're not editable and you can't change anything in payroll at that point.
Yeah, correct. You could still run payroll reports to find out what time has been done in the past, and there is an optional like cost breakdown on the work order you can use. Let's see if we can get to the settings here. Oh, my keyboard's wigging out.
Right.
A second.
Well, and William Chen might not have permissions to set settings.
No, he does.
Okay.
It's this dock I'm using sometimes messes up my keyboard, but so we have this optional payroll cost detail thing, and you can use a fixed rate on top of that if you want to not show the actual payroll costs to the mechanics or coordinator or whatever. And you can also limit it so that only the coordinator could see the basically there's two different roles in Maintain. You have your coordinators and your mechanics, and the coordinators allows you to schedule and plan for different mechanics, and the mechanic role allows you to just do work and schedule and manage your own time card and stuff. But then this breakdown, let me go in here. I don't know if I have any that actually have cost entered to them because I haven't processed payroll yet for any of this because it's my test system. But you'll see this cost summary, and this will show you your parts cost from POs. It'll show you your payroll cost from time cards, and it'll show your AP cost from any AP that's entered to that work order. And so that's one place you can kind of see that history is through the time entered in this payroll cost thing. But yeah, that the actual time card data will go away once it's processed. That the batch and the pay period won't be selectable anymore once it's been processed inside of Maintain.
Sharon asks also, is there any standard analysis or reports? Would that be done in Vista? Currently, all the reports that we've done have been in actually mostly SSRS inside of Vista. Of course, the data exists there. If for those of you guys who have your own report writers and that kind of thing, you can always they don't have to learn a new system in order to write reports. They can just go based on the existing data inside of Vista. The intention is that we will start to get some of the more standard reports inside of here as part of the dashboard. For example, understanding where on the 4 quadrants, for those of you guys who've been through like boot camp, know about the 4 quadrants. Where on the 4 quadrants a piece of machinery is, being able to look at and do some analysis on the over/under for the revenue versus cost for a piece of equipment over time, or for a rate category over time. Some of those things on the know your cost side, that is expected to get in here. Our first focus though is on reliability specifically. That is the number of red events, and be able to get the information out to the mechanics and get the information from the mechanics specifically around these red events. And so the very first reports that come out of this will be those things that help us analyze that. That is red events per 1,000 hours life to date. Sharon asked, the planner schedule you showed us was visible by the mechanic. Is there an overview showing all mechanics?
Yes, so I was logged in as a mechanic. Now I've logged back in as my coordinator guys actually, so I can show you. If I go here, then we can see the different mechanics and view their different schedules. And there's actually a setting here, allow mechanics to view all calendars, and this will mean if you're signed in as a mechanic, then you will be able to view other mechanics' calendars here, but not edit them. But the coordinator will be able to edit. So since I'm the shop coordinator here, I'm able to, so let's say, go on Jason Williams' calendar here, and maybe I schedule this repair damage tail light for Thursday. So yes, there is kind of an overview, I guess, with this thing, and then me and Duffy at AUI were planning on, I'm working with them to create maybe a comprehensive overview, I guess, that shows you like each mechanic, and instead of showing like every hour, it would just say basically like what work orders are on what days, and kind of give you like a bird's eye view of what the shop is up to in the next currently.
Cool. Good questions. Any other questions? One of the things that we're also offering as part of the beta program for any of you guys who are interested is that if you guys sign up, then the installation work order also comes with a mandatory on-site. So Brad actually flies out to your site and sits ideally in the same place that your mechanics, like, eat lunch or work something with the coordinator, and works directly with your mechanics to show them get everything installed, get everything set up inside of Vista. So help with standard maintenance group setup, help with cost code setup, help with whatever it is that is needed to be done. So he's been spending time on site and understanding exactly what they need. There's two parts to that. One is that we want to make sure that you guys get the right training, but and that's not just Kartaya Maintain training, but also Vista training. And then also that we hear directly from the people doing the work exactly what is needed, and that helps us prioritize the work and helps us understand that. So that's something that we're doing for the beta program. We don't know if we're going to be able to continue doing that for every company after the beta program is done, but yeah, it's something that we've been happy to be able to offer now. Like you mentioned AUI. In fact, Brad and Duffy, you guys are both on here. Brad Hendrickson came out and spent some time with you, and that was great. It really helped us out.
Yep, I really enjoy going on site and being able to get a good look at how people's operations are working too, because everyone's got a little bit different of a setup with how they're running their shop, and so being able to support all of those different workflows and backgrounds in Maintain is important to me. So it's fun to go on there and meet everybody and see what's going on.
Okay, any other questions before we wrap it up? Awesome. Well, thank you all for coming. I really appreciate it. And we're going to put out this recording. If you want to share it with anybody else in your organization, it'll be there on Teams. If you want it specifically emailed to you, Ryan can email that over to you. And anybody who is interested in getting a hold of that beta program, we would love to talk to you. And you can talk to either me or Ryan and in the office here, and we'll get you set up. Awesome. Thank you very much, everybody, and have a nice day. Thank you, Greg. Talk to you guys later.
Yeah, have a good one, guys.